Hello, Accelerated Math 6-7 students. We are working in a new module, and the new module is about number systems. So Module 8, and this is going to be Lesson 1. The name of our first lesson is called Real Numbers. Okay, so our goal for today. Today we are going to learn the differences of real numbers. The question that I want you to be thinking about during this lesson is, what are the differences of real numbers? Things to know. So in class, you guys created a little flip book about real numbers. And so as you can tell, this is where I need you to put this in your comp book. So things to know, a picture of numbers. And here is our flip book that we made. I would like you to go ahead and glue that into your comp book right there. And so just a quick reminder of our flip book. We have two kinds of numbers that we have in our number system, real numbers and imaginary numbers. Imaginary numbers you're going to deal with when you get into higher high school level math courses. And then real numbers are what we use in the middle school math classes, including algebra. And there are two types of real numbers that we're working with. We have the rational numbers and we have the irrational numbers. So if we open up our flip book, we can take a look at these two types. So let's do the rational number side first. Rational numbers include integers, whole numbers, and natural numbers. The irrational numbers actually are kind of special because they don't have any other types of numbers to make them irrational. They are just irrational. And so on this side of the flip book, we just did examples. So an example of an irrational number would be the golden ratio. This is how you find the golden ratio. 22 divided by 7, pi, the square root of 2, e, you will find this. This is Euclidean's number. And then the square root of 3. Those are just some examples of irrational numbers. All right, so this is how you have to try to organize your brain. This could be a really nice graphic organizer tool to help you remember. But you have to remember the difference of the different types. So we have rational and irrational. And so I would like you now to write down this part. And it says real numbers of our world belong to two categories. Those two categories are rational and irrational numbers. And so the next part of our notes that I need to go over with you is the different kinds that we have. And so we have irrational numbers, and irrational numbers are numbers that cannot be written as a fraction. So irrational numbers, the reason that they're irrational is that they go on forever. And the reason, hold on one second. Sorry for the delay. I had to go get my power strip because my computer says it's about to die. So let me plug it in, and then we don't have to worry about starting over. All right, so irrational numbers are numbers that cannot be written in a fraction. And the reason that they cannot be written in a fraction is because they are numbers that go on forever, that never repeat. And so when I say they go on forever, that means that they form parts of numbers. So you could have a whole number and then a decimal and then a whole bunch of numbers that follow them, but they never repeat and they don't stop. So they're not a terminating decimal, they're not a repeating decimal, they are just a sequence of numbers that go on forever and ever and ever. And so that is the reason why we can't write it as a fraction, because we never know what the last number in the sequence is going to be, giving us a decimal point that we could show. And so the number one thing to remember about irrational numbers is that they are numbers that cannot be written in a fraction. If a number can be written in a fraction, then it shows you that it is terminating, or that it's repeating, or it stops. Okay, and so irrational numbers can't. And then in our flip book, you wrote down some examples of that. So if you want to write down some more examples, you could say pi is an example of an irrational number. Square root of 2 is an example. Square root of 3. And I don't want to rewrite all of them, but this is just to help you visualize and remember it as we're going. All right, and as you know, we can't write pi as a fraction because we never know where it stops. You can't write the square root of 2 as a fraction because we never know where it stops. And you can't write the square root of 3 as a fraction because we never know where it stops. And so that's what you have to remember about irrational numbers. Rational numbers are numbers that can be written as a fraction. So they can be. So the biggest difference that you need to remember is irrationals cannot be written as fractions. Rational numbers can be written as fractions. And so if we look at the examples for these, we have negative 1/2. That is a fraction. 103 could be written as a fraction like this. So you would have 103 divided by 1. That technically is a fraction, and it didn't change the value because 103 divided by 1 is still 103. Okay? And then you have 7 and 25 hundredths. So to write that out as a fraction, it would be 7 and 25 hundredths, and that's what that looks like. So these three are examples of rational numbers because they can be written as a fraction. The thing that you need to remember about those is that all rational numbers that can be written as a fraction means that the denominator is never 0. Okay? All right, so now let's look at integers. Integers is the first type. So if we go back to our flip book, we have rational numbers right here, okay? And rational numbers can be written as fractions. And then you open it up, and the first type was integers. So we're going to the integers. Integers are all the positive and negative whole numbers, no fractions or decimals. So the thing you have to remember about integers, if we're looking at a number line, most number lines that are hung up in classrooms show integers. And the reason why they show integers is because we have 0, and then to the left of 0, you have all of these negative whole numbers, right? And then to the right, you have all of these positive whole numbers. And so the way that I like to remember what an integer is I visualize this number line. And integers usually are all of the numbers that are listed on those printed number lines that get posted in classrooms. That's how I remember it. So all of these are integers because integers are all the positive and negative whole numbers. That's the key part, is they have to be whole numbers. Integers cannot be fractions, and they cannot be decimals. So it's only the whole numbers, either positive or negative. Examples, negative 20, 20, 1, negative 1, 0. Those are all integers, okay? Whole numbers are all the positive numbers without fractions, decimals, or negative numbers. So whole numbers, you guys all know what whole numbers are because you've been learning about whole numbers since you were in kindergarten. Whole numbers are all the positive numbers. So our number line on this one starts at 0, okay, because it's all the positive numbers. So it would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So examples of this would be 0, 1, 2, 3, 108, 512, 1042, all of those. So the things you have to remember about whole numbers is they cannot be fractions, they cannot be decimals, and they cannot be negatives, okay? So hopefully you're starting to see a picture of what the different types of numbers are. Natural numbers are all the positive numbers above 0. I could type correctly. Sorry, kiddos. That's supposed to say 0, so let me fix that. Okay? All of the positive numbers above 0 without fractions, decimals, or negative numbers. These are also called, you might want to underline those when you write it, these are also called counting numbers. Okay? So examples of that would be 1, 2, 3, 4, 5, 6. Now here's my favorite example. If I drew this hand, and please don't make fun of my drawing, sorry. I know it's not gorgeous, but it gets the point across. So this is a hand, okay? And when you have a hand and you're putting numbers on up to show how many there are, how would you start counting those fingers? When you start counting, would you point to this one and say 0? And the answer is no, you would not do that, because when we count, we have a 1-to-1 correlation. And this little pinky right here is not 0. There's actually something there. It is one finger. So instead, what you would do is you would say 1. And then this one would be 2, this one would be 3, this one would be 4, and this one would be 5. So natural numbers are all of the numbers that you use to count, okay? And so again, if we're going to our handy dandy number line, so we wouldn't start at 0 for our natural numbers. So I'm going to put the 0 there just so that you know that this is a number line. But natural numbers start ahead of 0. And the thing you have to remember about natural numbers is that they cannot be fractions, they cannot be decimals, and they cannot be negative either. So natural numbers actually start right here at the 1. So it's all of these forward, okay? So that's what you have to remember about natural numbers. And natural numbers are counting numbers. So again, we don't start with 0, we start with 1 when we're counting. If I have these writing utensils, how many writing utensils do you see? Do you start with 0 and say 0? No, you say 1, 2, 3. There are 3. So natural numbers are the counting numbers, and that's what you need to remember about those. All right, so the last thing that I want to go over, just to help you, and I kind of did that down here, is I want to give you one more visual representation. And with this visual representation, hopefully between your flip book, right, and this visual representation, all these different kinds of numbers will start to make sense. I'm going to go get some other colors because you need to see those. Okay, so I grabbed some other colors that I want to use, and we're going to draw on this number line all of the different kinds of numbers that we have. So first of all, we're going to start with this whole number line. You can't see, sorry. This whole number line right here is going to represent, so I'm going to put a box around it. This whole number line right here is going to represent all of our real numbers. Okay? And remember how I told you there's imaginary? Well, imaginary are off somewhere else. Okay? So this number line right here represents the real numbers. So the first one that we learned about was irrational. Irrational is very hard to put on the actual number line because, again, we have no idea where it actually sits. We can kind of get an idea, like pi. Pi would be obviously in between 3 and 4 because you know that pi is 3.14 blah, 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 blah. But we don't know exactly where it is. So let's just say that pi is somewhere around here. So on your number line, you can draw that, and that will represent pi. That number is irrational. So I'm going to put a box around irrational in pink. So we know that the pink represents irrational. Okay? So then the other ones that we're going to do is we're going to put the rational numbers on there. So we can do that. So let's start with the ones that we know. So integers, and I'm going to go light blue with integers. Integers are all the positive and negative whole numbers, no fractions, decimals. So any of these. So this right here would be an integer. This right here would be an integer. This right here would be an integer. This, so as long as it's a whole number, those are integers. Okay, so I'm going to go back up here and I'm going to put a blue box around integers so that I know that my blue circles on my number line represent integers. Okay, so then I'm going to do whole numbers, and let's do whole numbers in red. Whole numbers are all the positive numbers without fractions or decimals or negative numbers. So whole numbers are actually going to start right here, and then it's every one of them to the right. So I'm just going to make an arrow that goes this way because all of those, as long as they're not fractions and as long as they're not decimals, all of those are whole numbers. So again, go back up to my notes, put a red box around whole numbers so that everything that you see on this number line that's red is considered a whole number. Okay, so then let's do the natural numbers. It says all the positive numbers above 0. So we can't include 0 on this one. So these are all the positive numbers that are above 0 because we consider those counting numbers. So again, we're going to do another arrow because when you can count forever. So it's all of them above 0 are considered natural numbers. So I'm going to put an orange box around natural numbers. Okay? Now, so the last thing that I wanted to do is let's go back to rational numbers again. Rational numbers are all the numbers that can be written as a fraction. And so I would like to put these on our number line so that you remember what rational numbers are. And I'm going to do it in green. So rational numbers are in green, and I'm going to plot that. So negative a half actually sits right here, and that is negative 1/2, and it's a rational number. Okay? The next one said 103, which obviously doesn't fit, but let's choose 5 instead. So 5 is a rational number. 6 3/4. Okay, 6 3/4 is a rational number. Okay, so as you can tell, rational number. Oh, let's do negative 4 1/2, but let's write it as a decimal. So this is negative 4 1/2, and so that would look like negative 4.5. Okay, and so what we have to remember about rational numbers is that they can be positive or negative. They can be written as fractions or as decimals or as whole numbers. Okay, and so hopefully this picture right here is another way for you to keep track of the different kinds of numbers that we're learning about and that we're working with. Okay, so let's go back to our goal one more time. Today we are going to learn the difference of real numbers, and we did by our flip book and by our number line on the next page and our definitions. And then what are the differences of real numbers? The two main differences are what? We have real numbers. The two main differences is that some are rational and some are irrational. Okay? And so now you have a good picture, a good definition with all these different definitions of the different kinds of numbers that we have. Okay? And that's all I have for you today. All right, kiddos. Thanks so much. Bye.